collision, sort of like a intro. Momentum is a quantity defined as the product of mass and velocity of an object. It's probably the most important definition. If you have a large mass or a large velocity, or both are large, you're going to have large momentum. So a 2,250 kilogram pickup truck has a velocity of 25 meters per second to the east, which is to the right. What is the momentum of the truck? Well, the way we get it is, since we're given 2,250 kilograms and the 25 meters per second to the east, momentum, which is denoted by P, is just going to be equal to both of those multiplied by each other. So all you have to do is multiply them, you get the momentum. Impulse, product of force and the time over which the force acts on an object, is one definition for impulse. The other definition is the change in momentum of an object. So I guess the idea is that when a force is applied over time to an object, it can cause a change in momentum. So since force times change in time is equal to momentum, and change, as we've dealt with change in temperature or any other change in physics, it's final minus initial. So force times change in time can be equal to mv final minus mv initial. Let's take a closer look at that. A 1,400 kilogram car moving westward with a velocity of 15 meters per second collides with a utility pole and is brought to rest in 0.3 seconds. Find the force exerted on the car during the collision. Now, there's a couple things we have to look at to break down this question. First thing we have to look at is they've given us the mass and they've given me a velocity, and then it's colliding with a utility pole and is being brought to rest. So that means that my final velocity is 0. And since we're moving westward with a velocity of 15, my initial velocity is negative 15. So that means I can get my change in momentum because it's mv final, the 1400 times 0, minus the mv initial, the 1400 times negative 15. So let's see what that looks like. So we're going to use the impulse momentum theorem, where F times change in time is equal to mv final minus mv initial. If I'm looking for the force, then I'm doing mv final minus mv initial divided by time. All we did was divide both sides of the equation by time. After that, we're just putting in the numbers. We have what we discussed before, the mv final minus mv initial divided by the time. Once you plug that all in the calculator, you get about 70,000.